Well, good morning, my little budding scientists. Hope you're doing well today. I'm excited to have you back in my kitchen for a science lesson. Before we set up today's experiment, though, let me share with you some of the results from your experiment of how can you melt an ice cube quickly. Again, you had some really clever ideas, and I smiled when I watched them. Some people shared it on a video, some just wrote it, but I could imagine what you were doing. One clever person took a hammer and they chopped their ice as hard as they could chop it and broke it down into little bitty slivers, and those, of course, melted quickly. So that was a good idea, although a little destructive. Another person thought that heat would be a good source to melt the ice cube, and they put their little ice cube in the baggie next to a lamp that was turned on. They placed it right by the bulb, and the heat of the bulb, of course, helped it to melt quickly. Some other people had clever ideas. They took their ice and put it inside their mouth in the Ziploc baggie, and of course, that worked well. And still several others decided that the force of friction, they put the ice cube in between their hands and used friction to rub, making heat, and that caused it to melt. All of your ideas were good. There wasn't one really that was better than the others. It was just that you had to think and problem solve, and that's what science is all about. And then maybe if you tried the experiment again at another time, you'd think of a different way to do it, and that's awesome. Anyway, for today, we're going to be talking about conductors and insulators of heat and cold. I've asked you to watch Mystery Doug from Mystery Science, and please don't do his experiment. We have an investigation of our own that I'd like you to try. But again, we're going to need ice. We're going to need some materials that you can make a mitt. Now, I've got two different kinds. Both of them can be used on my hand to pick up something hot. So if I pick up a pot that's really, really hot on the stove, a mitt will help. And if you have something baking in the oven, certainly you need a mitt or two to help remove it without burning your hands. Today they've come a long way. Our pots and pans have some insulators on them. They hold the heat in, keeping us from, when we touch it, keeping us from being burnt. So that's really clever. All of my pots and pans have some kind of rubberized material just for that. Even my serving pieces that I'm going to put into, say, like a hot soup or a stew, have the same material on it. So let's talk about what your choice is for the experiment today. I like you to be able to choose. You don't do both, just do one. On one of them, you're going to create some kind of a pot holder, something that will keep your hand from being burnt if you are picking up something warm. Now, it doesn't have to be a mitten. It could be something that you fit onto a pot or pan yourself. Could be on a long handle. Could be on tongs. That's up to you. Be creative. Think of something that maybe no one else will think of. And when we talk about trying to create a material that will keep you from freezing, like the poor polar bear who swims in icy water in the polar region, and in order to keep himself warm, he's lucky. He's got a big thick layer of blubber under his skin and a nice fur coat, of course, that protects his body and his organs from the extreme cold. So you can either design something to protect you from really cold, or something that will help to keep the heat from burning your hand. I'm anxious to see what materials you decide to experiment with. Please share the picture with me on Seesaw or put something into Google Classroom. And again, I will share the results with everyone else. So have fun, experiment, and share what you've learned. Bye.